There we go. So I'm not good with technology. All right, 2.18 with the bar. That means the 18s go forever. So, whoops, and I'm having trouble writing them. 18, 18, 18, forever. That you know. So how do we make it a fraction? Well, the 2 in the front is just 2. 2 in the front is just 2. Nothing magical there. What about the 0.18 bar? Well, it turns out when you have a repeating thing forever, it's that number over that many 9s, meaning 99. Now, we need to reduce that. But at first, that's the answer. Making sense so far? So, and then you got to reduce that, right? Divide by 9, top and bottom. What's that going to be? 18 divided by 9 is 2. 9 divided by 9 is... 99 divided by 9, is 11. So it's 2 and 2, 11. Somebody have their calculator? What is 2 divided by 11? I got my old crazy cell phone here. It's like 10 years old. They gave me for free when I signed up for the cheap deal at T-Mobile. So you guys probably beat me to it, right? It's 2 11, so I'm assuming it's 18 forever. Is that what it is? I don't want to be telling you anything false here. Good, thank you. Yeah, right. So it's right. Makes sense? So it's over that many 9s. So basically, here, let me give you the rule. Repeating decimals work the following way. If you have point, let's just say, ABC bar, which just means ABC forever. In fact, let me just give a best way would be give the pattern. Let me do that. If you just have one thing, point A, call it A bar, it's just going to be A over 9. If you have two things, AB bar, it's going to be AB over 99. Can you tell my A's? Maybe make those X's and Y's. My A's look like 9s. It gets confusing. So here we go. X, and this is XY. And if you have XYZ with a big bar, it's going to be XYZ over, guess what, 999, etc. So it just means over that many 9s. That's all it is. That's how you make a decimal that goes on forever. All right, so let's go back then. So let's do this next one. Express 1 minute as a repeating decimal part of 1 hour. So 1 minute is what part of an hour? What portion of an hour? If I said it took me a minute, what part of an hour is that? 1/60th, right? Because there's 60 minutes in an hour, so 1 minute is 1/60th. Right? Remember, a fraction is always the part over the whole, isn't it? So 1 minute is 1/60th of an hour, right? Okay, so then just hit the buttons on your calculator. If you just go 1 divided by 60 on your calculator, I'll do it with you, my little crazy thing here. And I'm getting 0.01 and then like 6s forever. I'm getting like a 7 right at the end. Y'all getting that? So then what does that mean? Do the 6s not really go forever? Or what? Anybody have a guess? Why is there a 7 there? At the end. It's always at the very end, huh? Your calculator, I'm reading your calculator's mind. I know what your calculator's saying. It's saying a 7, like mine is, at the very end. Why? It's rounding the last spot. They're all 6s. It's just rounding the last spot. Does that make sense? Because it's trying to give you the best answer it possibly can with however many digits it shows. And so when it gets to the last digit, it says, oh, I better round the last one to be accurate. So it rounds it to 7 because, anything 5 and above rounds up, huh? That's all. So it really is 6s forever. It really is 6s forever. So which answer is it then? Is it A, B, C, or D? Remember, the bar tells you the part that repeats. So what part repeats? Does the whole 016 repeat? Is it 016, 01? That's what that would be, right? That's not right. You guys with me? So let me write that out. Right? This one would mean 0.016, 016. That's not right. What would this one mean? 001 and then a bunch of 6s. No, it's just 01 and then 6s. This would mean O, and then see the part that's repeating? 1, 6, 1, 6. That's not right. It's D, huh? 0, 1, and then 6 is forever. Everybody good there? So you could use a calculator on that one. That'd be on the calculator part. You'll see when I get the practice exam out this week and rewrite them. So negative 5.696 bar, negative 5.6 with the bar over the 9.6. Well, they're all 5. Oh, next one's 5.696. They're all that except for the middle one. Okay. They're all negative 5.696 except for the second one. No, third one. So I blew it. It's the third one. And then there's one more. Okay, so they're all that, and then it's just where the bar goes. First two, all three, only two. Only two. Last one, and none at all. Whoop, wrong. Okay, is everybody good with that first off? So there's the question. They're all saying 5.696, except for the middle one, just has the 6.9. And then it's all about where the bar goes. So the bar on just the 9. So let me be really clear on that. So what's repeating here? I knew I was clicking something fun. Sorry. I'm still challenged with technology. What is that? Is it right? Yeah, all right. I don't know what I clicked. All right, 696. Bars right there. Okay, so let's write out what these numbers are. Here would be my suggestion. They're all negative. 5. What you should do is just write out maybe 5 or 6 spots and see the pattern. 5.6. Now what's going to repeat is the 9.6. 9.6. 9.6. 9.6. Good enough. Next one. Negative 5.696. And what's going to repeat is the whole 696. So keep everything lined up. Very important. See, yeah, maybe I should do this. You want to keep these spots lined up. Because that's how we're going to compare one with another. 696, 696, 696. See what I did there? Next one, negative 5 point, and now this one goes 696969, doesn't it? 69696. Next one, negative 5.69, and then just the 6 repeats. 6 is forever. And finally, this last one is negative 5 point, and then it's just 696, and it stops. No repeating. Now, what does that mean, stops? What is really after it? Zeros, Just fill in zeros, because it's right on 696 with 0 afterwards, All right. Now that we have them all laid out that way, I think we can easily see which one. So which one of those numbers is, which way do they want us to go? They want the from greatest to least. Now remember, they're all negative. So the greatest negative number is one that's least negative. Did that sentence make any sense? Right? If you have 0 here, negative 1, negative 2, negative 3. Who's the greatest number? The negative 1. He's the furthest to the right. And this is the middle, and this is the least. So the most negative is the least, right? If you're $3 in debt, you got the least amount of money. If your friend's only $1 in debt, they're doing better than you, right? So, with that in mind, when they say go from, put the greatest first, the greatest will mean the least negative. These are all negative. So which one of these is the least negative? Can you tell? Let's compare. 5.69, they all start off 5.69. So far, so good. Yeah, and then they all come with a 6 next. Yeah, they're all the same up to there, aren't they? They're all 5.696. Everybody's the same from there. After that, we're looking for who is the, what is it? I already forgot. The greatest, which means the least negative. Okay, we want the lowest negative. Who's next comes a 0, next comes a 6. This is where they break away from each other. They're different from one another in this spot first. So anybody least? This guy. He's number 1. Number 1. Lowest negative, which means greatest number. It's confusing, I know. Right? This is number 1 in the list. Because they want me to start with the greatest, and the greatest means the least negative. So he's the least negative, isn't he? He has a 0, and that's lower than 6 or 9, right? So he's the lowest. He's the least negative. So now, who's next? Who's next after him? He's the lowest negative. He's the least negative. So who's the next least negative? Well, these guys that have the 6, they're lower than the guys that have the 9, right? So go on for them. Next, after the 6 comes, so it's 69 versus 66. Who's lower? The 66. So this is number 2. So this is number 1, number 2. This is number 3. Right? So the lowest is the 0, followed by the 66 and then the 69. And then we have 2 left. 96, 96. In fact, 96, they're the same so far. 96, 96, 96, 9. Are they going to continue to be the same? I don't know. I better do a few more on those guys. I really don't know. Let's see. What was his pattern again? It was 9, 6 repeating. So where are we at? 9, 6, 9, 6. So next will come a 9 and then a 6. He just keeps doing that. What about this guy? This guy is 6, 9, 6, 9. 6, 9. Yeah, that's the same number. That's weird. Yeah, those guys are equal, aren't they? They are the same number. That's funny. All right, so either order on those two. Either order. All right, so let's go find the list. Which one has this guy first? He's the least negative, the greatest. So this guy with no bar first. Well, A does, B does, C does, or D. It's either A, B, or D. Who's supposed to come next? This guy here with the bar only on the 6. Yeah, he's got that. So who does he? Yeah, they all do. All right, they're all still in the running. Who comes next? Number 3. It's this guy with the bar in the 6, 9, 6. The bar in all 3. No, not him. Yeah, him and him. So B and D are still in the running, huh? Now, the other 2 can be in either order. Oh, equals. That's smart. Nice. Thank you. Good observation. It is B. Yeah, it's not true to say this one's greater. They're equal, aren't they? Surprisingly, even though they're written differently, huh? It's a tricky little question. We good there? So if you saw that on the exam, you would not be tricked, right? You would just laugh at it and say, I saw that. Right, we good? Guys, feel free to check out there. All right, so find 3 decimals between each of the following. So, all right, we're supposed to take 9.55 and 9.5 bar. So 9.5, I'm going to write them all spaced out, careful. 9.55, and down below it, or maybe I'll put it over here. So 9.55, and way down here at the bottom, 9.5 bar. So that'll be 5s forever. Whereas this has zeros afterwards, doesn't it? You with me? Tracking? You good? Okay, so I'm supposed to find 3 numbers in between those 2. So let's take a look. Is this list? Is this in between? Let's just go right down through it. 9.554. 9.554. Is that in between? Yeah, because 9.55, 9.55, 9.55, they're the same to there, followed by a 0, 4, 5. Yep, 4 is between them. Okay, how about the next one? 9.553. Yeah, 3 here. That's between them. 9.552. Yeah, 2. Well, that's it. Boom, that worked out well, huh? A. Those are... See, the other ones wouldn't work. See, 7. That's not between. We're talking about this spot right here. Being between 0 and 5. Third spot after the decimal, huh? It's all about that third spot after the decimal. Does everybody see that? So it's A. Is that okay? Am I going too quick on that? See that? See how the 9.55 is just 5 zeros the rest of the way. And 9.5 bar is 5s all the way. So where are they different? The first 3 digits are all the same, 9.55, 9.55, 9.55. They differ the third place after the decimal, either 0 or 5. So in the third place, you got to go between 0 and 5 to be between them. So the third place being 4, 3, and 2 works. So the next one's the same thing. I'm going to move on or I won't finish. So I'm going to go on to making this more and more precise with decimals. So 0.4 bar, which you know is 0.44444 forever, and then 0.5, just straight that. Find a number halfway between them. How do we do that? We get a fresh screen here. So I'm going too fast for my pen. 0.4 bar and 0.5. So 0.4 bar and 0.5. Find a number in the middle, right? Halfway between, middle, same thing, right? So how do we find a number in the middle between those? And they give me some multiple choice options here. You know, boom, 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 boom. What do you think? Any ideas? Do what? Where's that voice coming from? Oh, I'm making fractions. It's just in my head. Yeah, make a fractions. Yeah, good idea. Why? Why are you thinking that way? I think you're right on the money. What makes you think that way? Yeah, right. Yeah, why is it we couldn't just leave them as decimals? Why is it we can't just say, so let's think about that for a minute. Why can't, you know what 0.4 bar means, right? It means, 4 is forever. And oh, there's not a bar in the 5. Did I mess up here? Just tell me when I do crazy things like that. There's no bar in the 5, right? Where are we at? Where's this problem? Yeah, right there. No, hello. There we go. No bar in the 5. So anyway, yeah, why don't you just enter that in your calculator and enter that in your calculator? And then do what with them, though? Do what with them? How are we going to find the middle? Yeah, what if I told you, hey, you got a 70 on the first exam and a 90 on the second. What's the middle? What would you do? Add them and divide by 2, huh? You know how to find the middle of two numbers. It's called averaging, isn't it? You add them and divide by 2, right? So when somebody wants you to find the middle of two numbers, you add them and divide by 2. So, okay, why don't I just put this into my calculator, add them up, get the total. My pen is going so slow today. Get the total, and then divide it by 2. Does that make sense? I'm not writing that very neatly. Let me do that better. So yeah, so why don't I just do that? This, just 4's forever. Add it to 0.5 and divide by 2. You guys got it? Let's do it. All right. Now you got to do it exactly that way, though. All right. So you got it? I'm getting 0.47 with 2's forever. Did you get that?
I didn't get the 2's forever, but I did get the 472.
Just 472? How many 4's did you enter in the first situation then? 3. Just 3? See the dot? Yeah. You see the problem we're having? We can't put 4's forever in our calculator. And you think, oh yeah, we'll just go close enough. Well, no, close enough isn't going to get it here because these answers have bars. 3 of them do anyway, which means the thing has to go forever. So I think the answer, I think I did get close enough. I put in like 10 of them is what I did. So basically there's 2 ways you could do this problem. You can type in a whole bunch of 4's here. I did like 10 of them. Instead of just 3, when I just now typed into my calculator, I went 4, like 10 of them, many as I could, filled the screen, Add 0.5, divide by 2. Now make sure you hit equals or enter or whatever when you're done with the numerator, so it'll finish that answer before you divide. Otherwise, if you just go straight to divide, it'll only divide. If you just go 0.444, let's do a plus in there, huh? Plus 0.5, and then you just go divide by 2 without hitting equals, it will only divide the last number by 2. It won't know you mean the whole total divided by 2. So you have to hit equals at the top, like give me the whole total, now divide by 2. Anyway, you guys able to get this kind of answer, doing that? So then that's going to be answer C, right? On that, showing fractions is because of the fact that we can't really put in 4s forever. So as soon as we stop, we're actually estimating. We don't have the real number. Does that make sense? It's a little different. So, but anyway, it worked out okay. We're just doing just do like 10 4s. It'll be good enough. Do as many as you can. Make sense? That good? Add them and divide by 2. Number 7. They're giving me 3/5 and 0.60 bar. You guys have your calculator? What is 3 divided by 5? Should come out 0.6. And then they're also giving me 0.60 with the bar over the 60. Now what does that mean? With the bar over the 60. Isn't that the same thing as just 0.6? No, because it's 60, 60, 60, where the 0.6 is just O's the rest of the way, huh? Everybody good on the difference? So now they want numbers. What do they want? 3 numbers between. So basically they're saying which numbers are between them. Select all that apply. So how about this? It's 6060, isn't it? And this is it's like looking at 6,000 and 6,060, just to make it easy. It's like looking at 6,000 and 6,060. Say which ones are between. Is 6,032 between 6,000 and 6,060? Yeah, check. Is 6,025 between 6,000 and 6,060? And the reason I'm stopping 4 places is because that's what they're doing in all their answers. So I'm just comparing 4 places. So, yeah, it is, right? How about E here? 6015? Is that in the middle? Is that between them, I mean? Not right in the middle, but between them? It is, huh? What about 609? It's not, is it? Because really, what do you really put at the back when there's nothing back there? 0. So it's really 6090, which is down here. 6090 would be more than 6060. It's not between, right? If I said, yeah, there's between 6,000 and 6,060 people there. 6,090 is not between. So that was not. So no. How about point? No, that doesn't even have a 6. No way. That's no. It starts with an O. How about 6065? Too big. No. So it's these other 3. Making sense? All right. I'm going to move on. You guys have your calculator? Well, let's do it. I would give you your calculator for this kind of a question on the test. You'll have your calculator for most of the questions. Just be a few where we don't. Anyway, I'm getting 0.571428. 5714. There's where my little cell phone calculator stops. You getting something like that, depending on how big your screen is and how far it goes? That's all I get. How am I going to find they want the 21st digit. In other words, this is the first digit. This is the second. This is the third. The third is a 1. The fourth is a 4. The fifth is a 2, etc. They want me to go all the way down to the 21st digit. What in the world is it? How am I going to figure out the 21st digit? Because it's a pattern. Huh? Do you see the pattern? Just follow the yellow brick road. Just follow the pattern. Right? So now what's the pattern? What's the repeat? Remember, what's the repeat? Every fraction has a repeating pattern in its decimal. They all do. No exception. So what do you see the pattern? See when it starts to repeat? 571428. 571428. Must be. Now how many digits is that? How many in the pattern? 6 here. 6 here. So then we're going to have another 571428. 571428. That'll be 6 numbers. 6 numbers. At that point, I got 24 numbers. This is the 24th number, right? Because 4 times 6 is 24. So this is the 23rd, 22nd. There it is. The 21st is a 1. 21st digit must be a 1. See how we did that? I just wrote it out, following the pattern. That's math. Math is patterns. In the end, math is patterns. Good there? All right, I'm going to keep moving. So be on YouTube if I go too fast. I just want to finish up for you. How are we going to do that? Are we going to write out 5,280 digits? No, that's obviously not our plan. Well, you guys have the calculator? I'm going to, we'll start there. 6 over 17. I'm getting 0.3529 for 11765. I assume it starts to repeat right there. Anybody go a little further than me? Is it 29 next? Or are you getting about the same number of spots I am? As soon as I see this right here, this pattern with the 5, 529411176. I assume. Anybody get further? Anybody got like a graphing calculator or something? You got a lot of spots there? Oh yeah, you got a lot. Okay, I should turn mine sideways too. 0.35294117. Oh, mine rounded. Good thing I'm going to use yours. Thank you. Thank you. Yeah, no, so much for mine. I got to get a new cell phone. I rounded. So it's 470. My son, he sells cell phones and stuff for Samsung, and I was like, well, I'll get a new cell phone. Do they have something for $100? He's like, $100, Dad? And he's like, they're like 3 to 5 or 1,000. I'm like, that's crazy. That kind of money for a little dumb little phone? Anyway, that's my problem. That's why I talk about the phone forever. All right. So thank you. So there's a little more. Actually, thank you, Jose. There's a little more accuracy. So, what's that?
There's more.
Is there more?
Yeah.
What do you got?
0.3529411764705882.
Oh, so after the 2,
yeah.
It started over again.
Yeah.
Is that right? That whole thing is the pattern?
The 3 is included in it as well.
So after the 2 comes another 3, 5, 2,
Yeah.
the whole thing again.
Yeah.
Wow. Thank you. So that's a crazy one. So it's repeating that whole pattern. So I'm not going to give you one like that where you need some special technology, because I don't have it either. So, but I will give you one on the test that repeats like 3 or 4 places, just 3 or 4 places. And I will ask you to go way out, though. I do think that's valuable, because that's math logic. So how can we use math logic? I don't care about technology. I don't pay for technology. But I do care. My job is to help you to think more and more logically, mathematically, to help those little minds that you will teach. So how do we, how do you take that thing and find now the 5,280th digit? Let's figure out how many digits are here first. What do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 digits, and then it just keeps repeating. Everybody good on that? Everybody understanding that it just keeps repeating like that? Right? What Janelle was saying on that? It started the 3, 5, 2 thing again after that. So 16, it goes 16 digits, 16 digits, 16 digits forever. Repeats that pattern of 16 digits forever. So how am I going to find the 5,280th digit? Any ideas? 16 digits, repeating pattern. What am I going to do?
Should you divide the number of digits they're asking for by the number of digits there is before they're repeating?
So divide 5280 by 16?
I can't.
I think that's a great idea. Do you see the feel of that? Yeah, Giselle, right? That's a great idea, Giselle. Does everybody see what Giselle's saying? Yeah, because we know 16 digits, 16 digits, 16 digits. So basically we're saying if you want to go all the way out to the 5,280th digit, you got to see how many of these groups of 16 it takes to get out to the 5,280th digit. Right? So how many groups of 16? So take your calculator, right? And take 5,280. I don't think it'll be clean. 5,280 and divide by 16. What does the calculator tell you? 330 with like a decimal point. Oh, just right on the money? 330 like bang on the money? Oh, well that's super convenient. So what does that mean? That means there's exactly 330 of these to get out to the 5,280th digit. So what does that mean is the 5,280th digit? It ends right there. It ends right there. Because that means the string is 330 exactly of these. 330 of those to get out to the 5,280. And the last number in the last string is the 5,280 digit. So it's 2. Now, honestly, I'm going to make it a little more tricky than I thought they did. I won't make it in right on the money. I'll show you. I'll give you the practice exam. I'll go over the practice exam with you. I'll show you. But I'll make it like, because like what if it doesn't end right on the money? Like what if this came out some decimal? Then you would need to find the remainder, which would be how far into the next string. If the remainder was, if it didn't go in clean, and there was a remainder of 3 or whatever, that would be the 3rd digit in. If there was a remainder of 5, that would be the 5th digit into the next group. And I'll go over that. I'll put that in the practice exam and go over that. But normally they made that kind of nice that way, even though they made the technology part crazy and the math part easier. I'm going to make the technology simpler. But the math part, I want you to be able to think about remainders as well on that. I'll give you one of those in the practice. Yeah, so 0.8 bar, right as a fraction. Let me just take a fresh screen here. So number 9, part A, they say, what is it? 0.8 bar. So 0.8 bar. How do you write that as a fraction? Remember we talked about that? What's that going to be as a fraction? 8 over 9. You just put it over however many 9s. Huh? And the next one is going to be 0.08 bar. So the next part, 0.08 with the bar over the whole 08. Yeah. And so what's that one going to be? 8 over 99. You see, the number of places is the number of 9s on the bottom. So if the bar goes 2 places, you got 2 9s. Next, they're going to go 0.008 bar over the whole thing. So what's that one? 8 over 3 9s. Yeah, 999. Exactly. So there's the pattern on that. Okay. Now, math is just patterns. It is. That's all math, just patterns. Now they're going to say, all right, what do you think about this one? What is this? 1, 2, 3 O's. Well, it's just one more. It's going to be the same thing. We don't need that. Let's go into part C. 8 over 9,900. That's more tricky. Part C says, okay, now what do you think about 8 over 9,900? What's that? Now, I would give you this on the no calculator part. Because I know you can all just hit the buttons on your calculator without even thinking. But I want you to be able to think. So this would be on the no calculator part. Can you look at that? I hope you can look at that now. And think, what would that be decimal? Now, it's a little weird. Let me show you how you problem solve. That's our whole next unit. Unit 3 is about word problems and thinking about how you problem solve. So let's begin some of that now. What do you do when you look at some crazy question? I haven't given you one exactly like this. If that was 9s all the way, right? If that was 9s all the way, you could totally do it, huh? It would just be, what would that be? What if it was 9s all the way? 3 zeros, right, and an 8, huh? Because that'd be 4 places, 4 nines, with a bar, I mean. And we're good. If they gave you 9s all the way. That's the rule we've learned, huh? We've learned that if they give you 9s all the way, 3 9s is 3 things with the bar. 2 9s is 2 things with the bar. 1 9 is 1 thing with the bar. Right? But they didn't give me 9s all the way. They gave me a couple of 9s and then a couple of zeros. So that's different. What do you do about that? Well, think this way. One of the strategies that you want to employ when you solve problems that are, new and creative, you really can learn to think, and that's a lot what you want to give to the young people, is to think creatively and logically in a brand new situation where you don't already have step 1, step 2, step 3, a recipe for solving the problem. Much better, and engineers and architects and some of those little brains sitting in your classes will be those people one day. You want to help them to start using their minds to think outside the box, to be able to say, okay, I don't have, this isn't like a pre-packaged meal here. This isn't, I don't have a recipe already for this one. I'm going to have to use a little logic. So here's one good strategy. Start with what you do know and kind of build from there. If they just gave me 8 over 99, and they didn't, it's those zeros that are bugging me, huh? So let me just peel those off at first. This is a lot of what I learned to do eventually, as they tortured me with a million math and science classes, is I eventually, having to solve zillions of problems, learned the strategy to take what I do know and get rid of what I don't know and think about what I can do with that. So if they just gave me this, I would know how to handle it, right? It would be what would it be? 0.0 bar, 0.08 bar, wouldn't it? If they just gave me that. So that I could do. But they gave me these stinky 2 9s at the back. 2 9s, 2 zeros at the back. What do I do about those? Is there any way that you know of that you can take a denominator and make 2 new zeros pop up on it? How can you add 2 zeros to any number? Multiply by 100, right? So that means if I take this number and I go, multiply the bottom by 100, and that'll put the 2 zeros there, right? 100 times 99 is the 9900, isn't it? Okay, great, so what? Well, what does that do to a decimal when you multiply, because this decimal is from this guy, and then I put the 100th there. What does that do to a decimal number if you multiply it by 1 over 100? 1 over 100 is the same as dividing by 100, right? Because it's 100 in the denominator. If you divide a number by 100, what happens to the decimal? 2 places back, huh? If you multiply by 100, 2 places forward. If you divide by 100, 2 places back. So that means it's the 0.08 bar, but the decimal goes 2 places back. It must be 0.00 and then 0.08 bar. The bar's still on that other 0.8. There's our answer. I wrote it kind of funny. It was spaced out there, which you don't want to do. There we go. There's the answer. So everybody see what I did? Do you see the logic I went through there? I just said, I don't know about them zeros, so let me just take what I do know. 8 over 99, that's 0.08 bar, right? And then how do you make that 9900? Well, multiply the bottom by 100. What happens when you multiply the bottom by any number by 100? The decimal goes back 2 places. It's divided by 100, effectively. Huh? And so the bar's not all the way, is it? The bar doesn't move back. The bar stays right where it was, just the zeros go in front when I move the decimal back 2 places. Is that good? That makes sense? And see how not only do you see the answer, but do you see the process through which I thought? I said, let me start with what I do know. Get that straight, 0.08 bar, and then think how I can do the new part. Right? That's a good way to attack problems. That's one here. Use the fact that 0.1 bar is 1/9, that you know, to figure out what's 0.8 bar. You know this already. 0.8 bar? 8/9. It's a funny looking 9. And what's 5.3 bar? It's 5 3/9. Hey, and what's 3/9? 1/3. And you know that already, huh? You know that 0.3 bar forever is 1/3. Come on, Tim. There we go. Right? That makes sense? You see that agreement between what we already know and the new fact we've learned? Let me say that one. Maybe you missed that. I'm kind of moving fast at this point. 0.3, what's 0.2 bar? 0.2 bar is, as a fraction, 2 over 9, right? We've learned it's always over 9s. So then what's 0.3 bar by that same rule? Every time I go fast, my pin wigs out. 3/9 by that same rule, which you already know is 1/3. Sure enough, 0.3 bars is 1/3. I think a fact you already knew, huh? See how, isn't that, I love the way the math truth always fits beautifully. All math truth fits perfectly with one another. All right, number 11, and we're out of time. Let's see, 0.01 bar. Yeah, so same thing, 0.82 bar. You know that, 82 over 99. And that one you could do as well. All right, good. We're out of time. You've got all that stuff.